Good morning, students. So we have been discussing the architecture of MSP430 microcontrollers. Okay. So today let us study the clock generator inside MSP430 microcontroller. So this is the block diagram showing the clock generator inside MSP430 microcontroller. So as you can see here, inside MSP430 microcontroller, three different types of clocks can be generated. One is called as master clock, MCLK, SMCLK, submaster clock, and auxiliary clock, ACLK. So these are the three different types of clocks that can be generated in MSP430 microcontroller: MCLK, SMCLK, and ACLK. Okay. This MCLK and this SMCLK, they are in megahertz range. Okay. Their maximum value can be up to 16 megahertz. Okay. Whereas this ACLK, its value will be either it will be 12 kilohertz or it will be 32 kilohertz. So remember, this auxiliary clock is ACLK auxiliary clock is in kilohertz range. Its value will be typically either 12 kilohertz or 32 kilohertz. This submaster clock and this master clock, they are in megahertz range, and their values will be in terms of megahertz. It can be maximum up to 16 megahertz. This MCLK will be used by the CPU, okay, for executing the instructions mainly. So the CPU will work only with MCLK. So this MCLK will be used by the CPU and few peripherals which can work with this higher frequency, okay, such as your ADC or a watchdog timer, okay, they can use this MCLK. And this SMCLK and this ACLK will be used by the remaining peripherals inside MSP430. Okay, so there will be internally three different types of clocks that can be generated: MCLK, SMCLK, and ACLK. Now, how these clocks will be generated? So for generating these clocks, internally there are oscillators. Okay, so different oscillators are available inside MSP430 microcontroller. So in this oscillator there are two types. One is the RC based oscillator, that is resistor and capacitor based oscillators. So this VLO, very low frequency oscillator VLO, and digitally controlled oscillator DCO, these two oscillators are the RC based oscillators, that is resistor and capacitor based oscillators. So the frequency of the clock that is generated by this VLO and this DCO can be varied by varying the values of R and C. But their disadvantage is the accuracy of this VLO and this DCO is quite less. Okay, so this very low frequency oscillator and DCO, they are RC, resistor and capacitor based oscillator. Their frequency can be varied, but their accuracy is quite low. And the other two types of oscillators that will be present in MSP430 is LFXT1 and XT2. So this LFXT1 stands for low frequency crystal oscillator and XT2 stands for high frequency crystal oscillator. Okay, so these two oscillators, they need an external crystal to be connected to generate the clock pulse. Okay, but their advantage is their accuracy is quite high compared to this VLO and DCO. The accuracy of these crystal based oscillators is very high. Okay, now how these clocks will be generated? So we have different oscillators here, as you can see. Okay, to generate this ACLK clock, either we can use this very low frequency oscillator or we can use low frequency crystal oscillator. Okay, so this ACLK can be generated by making use of this very low frequency oscillator, or it can be generated by using LFXT1, that is low frequency crystal oscillator. Then what is the value of this clock that can be generated by this VLO? So the frequency of the clocks that are generated by this VLO, it can be up to 12 kilohertz. So the frequency of the clocks that can be generated by this VLO is up to 12 kilohertz. Then this LFXT1, so we need to connect an external crystal here. Okay, so what should be the value of the crystal here? So either we can connect a crystal of low frequency crystal of 32 kilohertz. Okay, we can connect a crystal of 32 kilohertz to this LFXT1, or directly we can give an external clock signal which can be in the range of 400 kilohertz. Okay, its value can be 400 kilohertz to up to 16 megahertz. Okay, so we can give an external clock pulse directly to this LFXT1. Okay, so this LFXT1 can be given, it can be connected to a crystal, low frequency crystal of 32 kilohertz, or you can directly give an external clock signal of 400 kilohertz to 16 megahertz. Okay, so then this LFXT1 can be used to generate the ACLK. Okay, so either we can use VLO or LFXT1. Then how to select which one of these should be used to generate this ACLK? So that selection can be done by using these selector bits. Okay, so by using these selector bits, okay, we can decide either you want to use this VLO to generate this ACLK, or you want to use this low frequency crystal to generate the ACLK. Okay, so this LFXT1X, so there is a selectors available. Okay, so by using these selector bits, okay, it is a multiplexer. We can select either we want VLO or LFXT1 to generate ACLK. So this LFXT1, this selection can be done in the software. By setting some of the bits, we can select either we are going to use VLO for generating ACLK, or we are going to use this LFXT1 to generate ACLK. Okay, then this SMCLK, okay, submaster clock can be generated. Okay, it can be generated by using either high frequency crystal oscillator. It can be generated using high frequency crystal oscillator, or by using digitally controlled oscillator. This high frequency oscillator, okay, XT2, either you can connect a high frequency crystal here, or directly you can give what? Again we can give a clock source, external clock source, which is in the range of again 400 kilohertz to 16 megahertz. Okay, so to this XT2 you have to give, you can connect an high frequency crystal in the range of megahertz, or you can directly connect an external clock signal of 400 kilohertz to 16 megahertz. Okay, so then you can use this to generate SMCLK. Okay, so this SMCLK can be generated either by using XT2 oscillator, or there is one more oscillator, that is digitally controlled oscillator. This digitally controlled oscillator, it works, it generates clocks in the range of few hundreds of kilohertz to up to few tens of megahertz. Okay, so either one of them, XT2 or DCO, can be used to generate this SMCLK. Okay, so there are again selection bits available for selecting which one of these oscillators you are going to use for generating SMCLK. Okay, then for generating this MCLK, either I can use DCO, digitally controlled oscillator, or I can use XT2. Okay, so this MCLK can be generated by using this DCO, or by using XT2, or by using VLO, or by using LFXT1. Okay, so any one of them can be used for generating the MCLK. So either again by using software, I can select which one of them, these oscillators, I am going to use for generating my MCLK. Okay, then after you have selected these oscillators, okay, so suppose for generating ACLK, okay, I have used this VLO or LFXT1. So I am going to select them by using selectors. Then suppose I have connected a 32 kilohertz crystal to this LFXT1. So this will generate a 32 kilohertz clock signal that will come here. Then that 32 kilohertz directly you can give it as ACLK, or you can divide this 32 kilohertz that is generated by this LFXT1 by 1, or you can divide it by 2, so that this ACLK will become 16 kilohertz, or you can divide it by 4, so that ACLK will be 32 kilohertz divided by 4, it will be 8 kilohertz, or you can divide the output of this LFXT1 frequency by 8, so that if it is 32 kilohertz, the frequency that is generated by LFXT1, then the output can be, if we divide it by 8, it can be up to 4 megahertz. So in this way, the frequency that is generated by these oscillators, okay, they can be divided by using these dividers. Okay, so the ACLK will be generated by VLO or LFXT1, and we can divide it by either 1, or we can divide it by 2 or 4 or 8. Okay, similarly this SMCLK, okay, this can be generated by using either this XT2 or DCO. Okay, then we can divide the oscillator output by either 1, 2, 4 or 8. Similarly, this MCLK can be generated by any one of the oscillators here. Either I can generate it by using VLO, LFXT1, okay, that will be coming here, then XT2, okay, then or by DCO, and we can select any one of them by using selector bits. Then the output that is coming here, we can divide it by either 1, or we can divide it by 2, or we can divide it by 4, or we can divide it by 8 to give the MCLK clock pulse. Okay, so this is how internally the different types of clocks will be generated by the MSP430 microcontroller. Okay, so by default, okay, if you can see here, by default, okay, so this ACLK will be by default, it will be generated by using LFXT1, so that is shown in a thicker line. Okay, so by default ACLK will be generated by using LFXT1, low frequency crystal. Okay, it will be used for generating the ACLK. So ACLK will be generated by using LFXT1 by default. And what is the value of this output that is generated by LFXT1? So the typical value of LFXT1 is up to 32 kilohertz. So a 32 kilohertz oscillator, the crystal will be connected here, and this LFXT1 is used by default to generate ACLK, and the output of this ACLK will be usually 32 kilohertz. Then what about these two, SMCLK and MCLK? Okay, so by default, as you can see here, it is shown by a thicker line. So MCLK will be generated by this digitally controlled oscillator. Okay, and again this SMCLK will be generated by this DCO, that is digitally controlled oscillator. So both this SMCLK and MCLK, they will be generated by default by the DCO. And what is the typical value of frequency? It is in the range of 1.1 megahertz usually. Okay, now so for example, as you can see here, I wish to run a CPU at 8 megahertz for rapid execution of the instructions. So what I will do, I want my MCLK equal to 8 megahertz. I want the processor to run at 8 megahertz. As you know, the processor can run only with MCLK. So I should generate MCLK of 8 megahertz. Then I will set my DCO clock equal to 8 megahertz. Okay, so that my MCLK will be equal to 8 megahertz. Okay, so CPU can run at 8 megahertz if I set my DCO clock equal to 8 megahertz. Then on the other hand, so what I want, it may be convenient if the peripherals run from a slower clock. So peripherals will be usually slow compared to the CPU. In that case, suppose I wish to configure my SMCLK, okay, of 1 megahertz. I am generating my MCLK equal to 8 megahertz, but I want to generate my SMCLK submaster clock of 1 megahertz. At that time, what I can do, I can divide this DCO clock. Okay, so this DCO is used to generate both this MCLK and my SMCLK. Now MCLK I want 8 megahertz. So what I will do, I will set my DCO equal to 8 megahertz. The same DCO is being used to generate what? SMCLK. So but I want the SMCLK of 1 megahertz. So the DCO clock is 8 megahertz now. So what I will do, to get 1 megahertz of SMCLK, I will divide the DCO clock by 8 megahertz. 8 by the value of 8. So 8 megahertz divided by 8, I will get 1 megahertz. Okay. So in this way, I can configure the values of different clocks inside MSP430 microcontroller. Okay. So again, the different peripherals have their own dividers for their clock sources. Okay, which gives us again a more very much accurate control over the clock. Okay. So this is how the clock generation system works in case of your MSP430 microcontrollers. So just remember, there are three different types of clocks. One is MCLK master clock, which is in the range of megahertz. Okay, it will be used by default by the CPU. The CPU will not function without MCLK. Then we have SMCLK submaster clock. It will be used by the peripherals. Then we have ACLK, that is auxiliary clock, which can again be used by the some of the peripherals. Okay, this is how the clocks, different clocks will be generated inside your MSP430 microcontroller. Okay, thank you.